therefore, if I take this point A of x1, y1, z1, b of x2, y2, z2, then if I take this point as p of x comma y comma z, if it divides in the ratio m is to n, then p can be written as p of x comma y comma z, p of x comma y comma z is equal to mx2 plus nx1 by m plus n. This is x coordinate. my2 plus ny1 by m plus n. Next, mz2 nz1 by m plus n. So therefore, when p is dividing the line joining of the 2 points a of x1 y1 b of x2 y2 in the ratio m is to n, then I can write what? mx2 plus nx1 divided by m plus n, my2 plus ny1 by what? M plus n, mz2 plus nz1 by m plus n. If it is external, if p is an external point of a b dividing the same ratio, where p is an internal point of AB, right? Now I can also write mx2 minus nx1 by m minus n, my2 minus ny1 by m minus n, mz2 minus nz1 by m minus n, when p is an external point of AB. So therefore, then I can also write, now look here, sometimes I want to find out, he gives P, he gives A, he gives what? B. I want to find out the ratios. So therefore, now the note 5 is the ratio in which the point P with the position vector xi plus yj plus zk divides the line joining A of line joining A comma B whose position vectors are x1 y1j z1k, x2i y2j z3k respectively, which implies m by n is equal to minus of x minus x1 by x minus x2 or minus of y minus y1 by y minus y2 or z minus z1 by z minus z2. This how you got, so this one is, you solve this. How to solve this one is, if you solve this one is, how you got this one is, you take x. From the previous note, if x is equal to mx2 plus nx1 by m plus n, cross multiply mx plus nx, mx2 plus nx1, you transfer, this is x minus x1, x minus x2 plus n into minus of x minus x1. So therefore, m by n is equal to minus of x minus x1 by x minus x2. This is how this formula you can apply when the ratio is given, when A and B is given. You can apply this formula when the ratio is not given. When P is given, A and B are given. So therefore, hereafter we come across about, so the ratio in which the point P with position vector xi plus yj plus zk divides the line joining A comma B whose position vectors are x1i plus y1j plus z1k, x2i plus y2j plus z2k, z3k or else z2k respectively. Then m by n is equal to minus of x minus x1 by x minus x2 minus of y minus y1 by y minus y2 minus of z minus z1 by z minus z2. So how we got means I explained. Take x is equal to what? mx2 plus nx1 divided by m plus n, cross multiply, you will get m by n is equal to minus of x minus x1 by x minus x2. In the same fashion, you can also find out y ratio, you can also find out what z ratio. Sir, then you have three ratios. Yes. So if you, which ratio we have to go for? It all depends upon the students. You can go by any ratio. When this is not defined, you can go by this. When this is not defined, you can go for this. So therefore, all the ratios will be what? Same only. So therefore, this is the ratio in which the what? P of x comma y comma z divides the line joining of the 2 points A of x1 y1 z1 b of x2 y2 z2 in the ratio ms to n. Yes. After knowing this what comma ratios, let us move how to find out what? The centroid of a triangle. Centroid of a triangle. Corollary. If C of C bar divides the line A of A bar, B of B bar in the ratio m is to n, then C bar is equal to mb bar plus nc bar by m plus n, which implies A comma B comma C are collinear. Now if I take A of A bar, C of C bar, B of B bar, so we have to show that they are collinear. Now what is given? C bar is equal to mb bar plus nc bar by m plus n. You cross multiply mc bar, nc bar, mb bar plus nc bar. So therefore, now C bar, this is NA bar, this is NA bar, this is NA bar, which implies, group the terms, m into C bar minus B bar, yes, plus that is n into C bar minus A bar is equal to 0. So therefore, I can write, so which implies that is m into s come on BC bar plus n into AC bar is equal to 0. Therefore, BC bar is equal to minus n by m into what? AC bar, which implies BC bar comma AC bar are what? Collinear. So therefore, whenever you come across, then certainly what? They are collinear. and it divides in the what ratio? M is to N. M is to N, right. Now I am going for next. Centroid of a triangle. Yes. In a triangle, I am going to take A of A bar, B of B bar, C of C bar. A of A bar, B of B bar, C of C bar. And this is centroid. SG bar, right? Now, if I draw this a midpoint, we can also go for this is, it's a midpoint. This is also what? Midpoint. So therefore, in a triangle ABC, let D, E, F be the midpoints of the sides. Midpoints of the sides. Now AD, BE, CF are the medians. The medians always meet at opposite side in a midpoint. They are not perpendicular. The point of concurrence of medians of a triangle is known as centroid. And centroid divides the median in the ratio 2:1. Median always divides in what ratio? 2:1. So therefore, this also 2:1. This also 2:1. This also 2:1. This also 2:1. Now, I start. What is centroid? The centroid, the point of concurrence of medians of a triangle is known as centroid. Now, you can very well observe D, E, F are the midpoints of sides BC bar, CA bar and AB bar respectively. So therefore, I can write OD bar is equal to OB bar plus OC bar by 2. B bar plus C bar by 2. OE bar is equal to, similarly, C bar plus A bar by 2. OF bar is equal to A bar plus B bar by 2. Now, let us find out for this the point which divides AD in the ratio 2:1 is, let it be OZ bar I take 2 into OD bar plus 1 into OA bar by 3. Yes, now 2 into OD bar. What is OD bar? B bar plus C bar plus A bar by 3. Therefore, this is nothing but now the point which divides in the ratio. Now look at 2 into OE bar plus 1 into OB bar whole divided by 2 plus 1. You will get once again A bar plus B bar plus C bar by 3. So therefore the point CF, therefore OZ bar is once again A bar plus B bar plus C bar in the same fashion. It means that all the 3 lines AD, BE and CF are concurrent at same point, that is Z, whose position vector is what? A bar plus B bar plus C bar by 3. That point of concurrence of medians of a triangle is known as centroid. Therefore, hereafter, what is the position vector of a centroid? You can very well observe the point which divides AD in the ratio 2:1 is also A bar plus B bar plus C bar by 3. We have taken as OZ bar. For B also, OZ bar is equal to A bar plus B bar plus C bar by 3. For CF bar also, OZ bar is equal to A bar plus B bar plus C bar by 3. It is quite evident that the medians of a triangle are meeting at the same point. I mean, the point of concurrence of the medians is what? G. That point G, later we call it as what? Centroid of a triangle, which is dividing the median in the ratio 2:1. Hence, its position vector is what? A bar plus B bar plus C bar by 3. Hereafter, what is the centroid of a triangle with the position vectors of the vertices? A bar, B bar, C bar is given by A bar plus B bar plus C bar by 3. I mean, OA bar plus OB bar plus OC bar by 3. So therefore, I can also write OZ bar is equal to. So we have proved OZ bar is equal to OA bar plus OB bar plus OC bar by 3, which implies 3 into OZ bar is equal to OA bar plus OB bar plus OC bar by 3. Right? OA bar plus OB bar plus OC. So therefore, now similarly, for the triangle A dash, B dash, C dash, let G dash be the centroid. Be the centroid. So therefore, we can also write similarly 3 into OC dash bar is equal to OA dash bar, OB dash bar, OC dash bar. Now, my question is, theoretical question is, so for this, you take this a triangle, A dash, B dash, C dash, now G dash. For this triangle, A, B, C, this is what G. When G and G dash are the centroid of the respective triangles, we could find out 3 into OZ is equal to OA bar plus OB bar plus OC. 3 into OZ dash bar is equal to OA dash bar plus OB dash bar plus OC dash bar. So therefore, I can write, the question is, The theoretical question is, let G comma Z dash be the centroids of the triangle ABC, A dash, B dash, C dash. Then GG dash bar is equal to dash. So therefore, the solution for this is, we know that 3 into OZ bar is equal to OA bar plus OB bar plus OC bar. OA dash bar, come on, subtract. This becomes 3 into OZ bar minus, okay, J dash, that is OZ, that is, this becomes OA dash minus OA, OB dash, OB, OC. Therefore, 3 into GG dash, next AA dash, BB dash, CC dash. Right? So therefore, we have proved 3 into GG dash is equal to what? AA dash bar plus BB dash bar plus what? CC dash bar, when Z and Z dash are the centroid of the two triangles. Centroid of the two triangles. After knowing the centroid, the position vector OZ bar is equal to OA bar plus OB bar plus OC bar by 3. Yes, now I'll go for this one is first. The first one is AC bar plus ZB bar, GC bar is equal to dash. So, next, the second one is, yes, GA bar plus BC bar plus GC bar is equal to dash. The third one is GA bar, GB bar plus CG bar is equal to dash. Now, what I have taken is, let G be the centroid of a triangle ABC. Therefore, OZ bar is equal to OA bar plus OB bar plus OC bar by 3. So now let us prove that. First one is, what is GA bar plus GB bar plus GC bar? What is this? You can add another one to this one is, GA bar is OA minus OZ, OB minus OZ, next OC minus OZ. I can write this one as OA bar plus OB bar, OC bar minus 3 times of OZ bar. But we know it already. OA bar plus OB bar plus OC bar is equal to what? 3. 3 into OZ bar. Now I can write 3 into OZ bar minus 3 into OZ bar is equal to 0 bar. Yes, we have proved GA bar, GB bar, next GC bar is equal to 0 or 0 bar. Yes, in a triangle ABC, the question is, in a triangle ABC, if G is a centroid, then The very first one is, you can take this as what? Come on, 1, 2, 3. Then we have to prove this one is, what is the corresponding the result. Before proving this one is, I want to prove GA bar plus GB bar plus GC bar is what is the corresponding result. Prior to that, let G be the centroid of a triangle ABC. Therefore, OG bar is equal to OA bar plus OB bar plus OC bar by 3. So therefore, GA bar plus GB bar plus GC bar is equal to, yes, every vector can be expressed as position vectors of its extremities. OA minus OZ, OB minus OZ, OC minus OZ, OA bar, OB bar, OC bar, minus 3 into OZ bar. But this is equal to, already we know it, 3 into OZ bar is equal to OA bar plus OB bar plus OC bar. So therefore, 3 into OZ bar minus 3 into OZ bar is equal to 0 bar. Therefore, we have proved GA bar plus GB bar plus GC bar is equal to what? 0 bar or 0. Then, let us prove what's the value of this. Yes, AZ bar plus GB bar, GC bar, OZ minus OA, OB minus OZ, OC minus OZ. But here, I can write this one as 1 OZ get cancels, and also minus OA bar, OB bar, OC bar, minus OZ bar. But here, actually we know it already, since 3 into OZ bar is equal to OA bar plus OB bar, OC bar. OA bar plus OB bar plus OC bar. I can write this one as add and subtract OA. OA plus OB plus OC minus OA. This is, it has come here. Add and subtract. It is already OA is there. Therefore, 1 OA, already 1 OA, it's a 2 OA minus OZ bar. But this value is equal to 3 into OZ bar minus 2 into OA bar minus OZ bar. Why? Here add and subtract OA, already 1 OA is there. Therefore, OA minus OA minus OA minus 2 OA. So therefore, now this becomes, you subtract these two, 2 into OZ bar minus 2 into OA bar. So therefore, that is 2 into OZ minus OA. So therefore, this is equal to 2 into AZ bar. We have proved ZA bar plus GB bar plus GC bar is equal to 0 bar or 0. In the same fashion, I have proved AZ bar plus GB bar plus GC bar is equal to what? 2 into AZ bar. So therefore, we can also prove this one, second one also. Yes, this is equal to 2 into AZ bar. Then second one is GA bar plus BC bar, GC bar, yes, is equal to, I'll start from here, OA minus OZ, OZ minus OB, OC minus OZ. So therefore, OA, OC, you take one side, OC, minus OB. Now this and this get cancels, minus OZ bar. Add and subtract OB plus OC. Already one OB is there, OB bar minus OB bar minus OZ bar. This is equal to 3 into what? OZ bar As you know already, OA bar plus OB bar plus OC bar is equal to 3 into OC bar minus 2 into OB bar minus OC bar. Therefore, this is equal to 2 into OC bar minus 2 into OB bar, 2 into what? BC bar. Yes, we have proved this value is equal to what? 2 into BC bar. Similarly, I can go for third one is, what is third one? GA bar plus GB bar plus CZ bar is equal to, from here, OA minus OZ, OB minus OZ, OZ minus OC. Next, so therefore, I can write this one as, add up these two, OA bar, OB bar, minus OC bar, this and this get cancels, minus OC bar. Add and subtract OC, OA bar plus OB bar plus OC bar, minus 2 times of OC bar, OC bar. Add and subtract OC. But this value is what? 3 into OC bar minus 2 into what? OC bar minus OC bar. So therefore, 2 into OC bar minus 2 into OC bar, 2 into S common OC minus OC is equal to what? CZ bar. So therefore, this value is equal to 2 into CZ bar. These are the corresponding results of what? The results of on the centroid. On the centroid. Yes, we have proved that is 3 into ZZ dash is equal to AA dash bar plus BB dash bar plus CC dash bar, where Z and C dash are the centroids of the two triangles ABC and A dash, B dash, C dash. In the same fashion, we have proved that is GA bar plus GB bar plus GC bar is equal to 0 bar or 0. Next, we have proved AC bar plus GB bar plus GC bar is equal to 2 into AC bar. Next, GA bar plus BC bar plus GC bar is equal to 2 into BC bar. Next, GA bar plus GB bar plus CC bar is equal to what? 2 into CC bar. Followed? Right. Now let us discuss about the centroid of a tetrahedron. The centroid of a tetrahedron. So therefore, tetrahedron is a three-dimensional centroid. Tetrahedron is a three-dimensional figure. This is what? A of A bar, B of B bar, yes, C of C bar, and D of D bar. Now, A bar, B bar, C bar, and D bar are the position vectors of what? 3 points, 4 points, A, B, C, D. Now, tetrahedron has how many faces and how many edges? Let us see. AB bar is one edge, AC bar is another edge, BC bar is another edge. Next, AD bar is another edge, right? Next, DC bar is another edge. Next, BD bar is another edge. It has 6 edges. It has 6 edges and 4 faces. And each face is a triangle. For example, now for a triangle ABC, ABC is a one face, what you can see. Next, triangle ADC, second triangle. Triangle BADB, next BDC, ABC, next ADC, next ADB, next BDC are the what? 4 triangles. Those 4 triangles represents the sides of a tetrahedron. So therefore, now certainly for a triangle ABC, D is not in the plane of ABC. So now this D, look here, D, when each triangle, there are 4 triangles. Now G is the centroid of what? Total tetrahedron ABCD. Let G be the centroid of tetrahedron Now G1 be the centroid of a triangle ABC. Let G1 be the centroid of triangle ABC. This is one face. G2 be the centroid of triangle A triangle A, or else you can go for BCD as you please. BCD. Right. Next, G3 be the centroid of a triangle what? CAD. And G4 be the centroid of a triangle ABD. Now remember, as I told, centroid divides the median in 2D triangle ABC in the ratio 2:1. Here the centroid of a tetrahedron divides the line joining of the centroid of a tetrahedron G divides the line joining of the centroid of a triangle ABC and the opposite vertex. For a triangle ABC, G1 is the centroid. So somewhere it is. And the line joining of D and G1 is divided by G in the what ratio? 3:1. Similarly, the centroid of a triangle BCD and the opposite vertex A is divided by centroid in the ratio 3:1. Similarly, the centroid of a triangle CAD and the opposite vertex B is divided by centroid in the what ratio? 3:1. But they are concurrent. The point of concurrence of lines joining the opposite vertex of each triangle, opposite vertex and the centroid of what? Line joining of what? Opposite triangle. It always divides in what ratio? 3:1. Let us see. Now if I take, let me find out G1 is equal to, or else OG1 is equal to the centroid of triangle ABC. OG1 is equal to A bar plus B bar plus C bar by 3. Next, OG2, centroid of a triangle, yes, come on, BCD is equal to B bar plus C bar plus D bar by 3. Now, OG3 is equal to centroid of a triangle CAD, which implies OG3 is equal to A bar plus C bar plus D bar by 3. OG4 is equal to triangle ABD. Therefore, OG4 is equal to A bar plus B bar plus D bar by 3. What it says? The line joining Z1 and opposite vertex D, opposite vertex D divides in the ratio 3:1. So now if I take this is what? Z1, or else divides opposite vertex D. So therefore 3:1, the line joining of the points D and opposite centroid, the line joining of D and D and Z in the ratio which divides in the ratio, or else some P you take it as P, in the ratio 3:1. So therefore I can write P is equal to 3 into, what is G1? That is nothing but A bar plus B bar plus C bar by 3. Therefore 1 into what? OD bar, or else D as you please, into D bar by 3 plus 1. Therefore 3 get cancels. I get A bar plus B bar plus C bar D bar by 4. If I go for this is, yes, C, if I take what? Come on, P, and this is what? C you are having opposite vertex. You take Z2. What is G2? G2 is the centroid of a triangle other than C. You take what? ABC. Correct or not? ABC. So therefore I can write C is there. ABD you take. What is ABD? This is nothing but A bar plus B bar plus D bar by 3. Correct. This divides in what ratio? 3:1. This is nothing but what? C bar. So therefore P is equal to, or OP bar is equal to, as you please, OP bar is equal to 3 into OZ2 bar. Okay, and 1 into what? OC bar by what? 3 plus 1, or else 3 into A bar plus B bar plus D bar by 3 plus 1 into what? C bar by what? 3 plus 1. I got it. A bar plus B bar plus C bar plus D bar. Similarly we can prove for what? Other angles. Now what? Come on. Yes, B and what? G3, A and what? Something G4. All for all those, the point of concurrence is what? P. It will have a what? Position vector A bar plus B bar plus C bar plus D bar by 4. Hereafter, what is the centroid of a tetrahedron? The centroid of a tetrahedron is given by A bar plus B bar plus C bar plus D bar by 4. So therefore the centroid of tetrahedron formed by the points A of A bar, B of B bar, C of C bar, next D of D bar is given by, yes, now OZ bar is equal to, or OP bar, as we proved, OP bar is nothing but OZ bar is given by, yes, come on, A bar plus B bar plus C bar plus D bar by 4 is same as OA bar plus OB bar plus OC bar plus OD bar by 4. From this definition, what we understood is the line joining the what? Opposite vertex to the opposite face centroid. Face is what? Triangle. So therefore, if I take a what? Come on, triangle ABC. Now this is A, this is what? B, it's a C. If I take this what? Come on, if I take this as what? D. Now for opposite vertex A, opposite triangle is what? BDC. Its centroid is let it be G1 or G2 or G3, G4, as you please. Now the line joining the what? Opposite vertex to the opposite face centroid, always which divides in the what ratio? 3:1. Means for AZ1 the point divides in the what ratio? 3:1. Similarly, for the point B, there's maybe G2 or G3 or G4. For BC2, which divides in what ratio? 3:1. For what? CG3, which divides in what ratio? 3:1. 3:1. Okay, so therefore we came to understand that in a tetrahedron, the line joining the opposite vertex to the opposite face triangle in the what ratio? 3:1. Hence, we have proved the centroid of a triangle, centroid of a tetrahedron as what? A bar plus B bar plus C bar plus D bar by 4. That is OA bar plus OB bar plus OC bar plus OD bar by 4.